Hello IB11s, we still have example 2. So let's look at this one again. So consider the function y equals 6 over x minus 2 plus 4. Okay, right now let's add these two parts up. So it's 6 over x minus 2 plus 4. I convert 4 to 4 over 1. If we want to add these two parts up, we need to find the same denominator. And you will find that the same denominator is x minus 2. We keep the first one, okay? And for the second one, we need to multiply the top and the bottom by x minus 2. So it's 4 times brackets x minus 2. And the bottom is x minus 2. So we can add the tops up. It's 6 plus 4x. Open the brackets for this part, it's minus 8. Then combine the like terms on the top, it's 4x minus 2 over x minus 2. So we will find that this function is exactly the same as a linear divided by linear. So in this case, when we want to look for the asymptotes, we look at the restriction in the domain. So right now the restriction in the domain is x cannot be 2, which means the vertical asymptotes is x equals 2. What is the horizontal asymptote? Let's leave this horizontal asymptote later. Okay, so we look at B first. Find the axes intercepts. This one is easier for us. Okay, so if we want to find the axes intercepts, we need to look for the x-intercept and the y-intercept. For x-intercept, let's say y equals 0. So 4x minus 2 over x minus 2 is 0. And for this rational equation, you know the bottom cannot be 0, which means only the top can be 0. So if 4x minus 2 is 0, this x value is 1/2. So this is the x-intercept. Okay, if you want to label this point in the coordinate system, let's label this one. So this is 1/2, 0. And we also can put the vertical asymptote on as well. So the vertical asymptote is x equals 2 right now. Okay. This is x equals 2. Let's find the y-intercept. Y-intercept is easier. Let's say x is 0. So let's plug x is 0 in. It's 4 times 0 minus 2 over 0 minus 2. So this one is negative 2 over negative 2. It's 1. So the y-intercept is 1. So this is the y-intercept. Pass through 0, 1. This point. So right now, let's come back to see how we can find the horizontal asymptote again. If I want to find the horizontal asymptote, we only need to look at when x approaches negative infinity, what is the y value approaching? When x is approaching positive infinity, what is the y value approaching? If you have trouble, the best way is I just pick up some x values. For example, x is negative 100, x is negative 1000, or x is negative 1 million, or negative 10,000 or 100,000. Let's look at what are the y values are for each x value. If you use the scientific calculator to find the y value when x equals negative 100. Find the y value when x equals negative 1000. You will find all those y values are getting closer to 4. So when x is approaching to negative infinity, y is approaching 4. The same idea for when x is approaching positive infinity. Let's say x is 100, x is 1000, x is 100,000. You find all the y values. Then you will find all the y values are getting closer to 4. So in this case, we will know the horizontal asymptote is this y value, which is y equals 4. So when x is approaching negative infinity, y is getting closer to 4 but never equals 4. When x is approaching positive infinity, y is getting closer to 4 but never equals. So this time we will know, okay, y equals 4 is the horizontal asymptote. So this is 4. And you will see the graph also pass through these 2 points. So for this part of the section, we can graph this hyperbola already. So one part of the hyperbola is this one. And for this part, when you continue to graph this hyperbola down there, it's getting closer to the vertical asymptote. And for the other part, so we know if we have one curve, this part, so one curve should be in this section. Okay, since we don't have enough space, we just leave them there. So the last step, of course, use the graphing calculator to graph this one. So this is your homework.